first we're going to draw a simple RC circuit, which consists of a resistor and a capacitor. So this is when you're discharging through the resistor. So that means that the total voltage is going to be 0 according to Kirchhoff's rule. So you have the voltage on the capacitor plus the voltage on the resistor equals 0. So like the other video, we learned that the voltage on the capacitor comes from the formula Q equals VC. And when you solve for V, you get Q over C equals V. So. And the voltage on the resistor comes from the formula V equals IR. And in this RC circuit, you see that the current is going around, and when it's going through the resistor, it's going down, which means that it's going to be negative. And so you see that that I and Q are the variables because they're changing, and R and C are the constants. To simplify I, in chapter 26 we learned that I equals dq over dt. So you can substitute that. And we'll move it to the other side. So you get Q over C equals R dQ over dt. And now you want to make the dq's and the q's stay on one side. So you have, when you simplify that, you'll get dq over q equals negative dt over rc. And from there, you can integrate that. And you want the left-hand side to go from Q initial to Q, and 0 to, on the right-hand side, you would want it to go from 0 to some time. And so you can pull out the constants on the right-hand side to get 1 over RC, the integral of negative dt from t to 0. And on the right-hand side, when you integrate that, you'll get ln of q from bounds, q to q initial. And so you're going to get ln of q minus ln of q initial equals negative t over rc. And you can simplify this to ln of q over q initial equals negative t over rc. And since you want it to be a function of q, you have to multiply, raise each side to the power e. So you have q over q initial equals e to the negative t over rc. And multiply q original, q naught to the right-hand side, you get q equals q naught e negative raised to the negative t